Remainders. If x and y are positive integers, there exist unique integers q and r called the quotient and remainder respectively, such that y is equal to divisor into quotient plus remainder is equal to xq plus r, and 0 less than or equal to r less than x. For example, when 15 is divided by 6, the quotient is 2 and the remainder is 3, since 15 is equal to 6 into 2 plus 3. Similarly, if you take a smaller integer divided by larger integer, you'll have 7 is equal to 11 into 0 plus 7. When y is divided by x, the remainder is 0 if y is a multiple of x. For example, 12 divided by 3 yields the remainder of 0, since 12 is a multiple of 3 and 12 is equal to 3 into 4 plus 0. The possible remainders when positive integer y is divided by positive integer x can range from 0 to x minus 1. Number divided by 10, remainder is the last digit of that number. 123 by 10, remainder 3. 123 by 100, remainder 23. Let us consider an example. If the remainder is 7 when positive integer n is divided by 18, what is the remainder when n is divided by 6? When positive integer n is divided by 18, the number is 7. N is equal to 18q plus 7. Now, since the first term 18q is divisible by 6, then the remainder will only be from the second term, which is 7. 7 divided by 6 yields the remainder of 1. So the answer is B. Let us consider another example. If n is a prime number greater than 3, what is the remainder when n square is divided by 12? There are several algebraic ways to solve this question, but the easiest way is as follows. Since we cannot have two correct answers, just pick a prime greater than 3, square it, and see what would be the remainder upon division of it by 12. If n is equal to 5, then n square is equal to 25. The remainder upon division of 25 by 12 is 1. So answer would be B. Let us consider this example. If s and t are positive integers such that s by t is equal to 64.12, which of the following could be the remainder when s is divided by t? S divided by t yields the remainder of r can always be expressed as s by t is equal to q plus r by t, which is the same as s is equal to qt plus r, where q is the quotient and r is the remainder. Given that s by t is equal to 64.12 is equal to 6412 by 100 is equal to 64 by 25, which would be equal to 64 plus 3 by 25. So according to the above, r by t is equal to 3 by 25, which means that r must be a multiple of 3. So only option E offers answer which is a multiple of 3. When positive integer x is divided by 5, the remainder is 3. And when x is divided by 7, the remainder is 4. When positive integer y is divided by 5, the remainder is 3. And when y is divided by 7, the remainder is 4. If x greater than y, which of the following must be a factor of x minus y? When the positive integer x is divided by 5 and 7, the remainder is 3 and 4 respectively. So x is equal to 5q plus 3. X could be 3, 8, 13, 18, 23, etc. And x is equal to 7p plus 4. So x could be 4, 11, 18, 25. We can derive general formula based on above two statements. Divisor will be the least common multiple of above two divisors 5 and 7, hence 35. Remainder will be the first common integer in above two patterns, hence 18. So, to satisfy both these conditions, x must be of a type x is equal to 35m plus 18. The same for y. X minus y is equal to 35m plus 18 minus 35n plus 18 is equal to 35 into m minus n. Thus x minus y must be a multiple of 35.